Hey everyone, I asked you to try sketching the curve y equals x over the quantity x squared minus 9. Let's try it together. Well, really, I hope that you first try this on your own and then take a look at the solution. Anyway, standard, I'm going to call this function f of x. Alright, so remember the 6 steps that we want to do, right? And I'll be more explicit about this on quizzes or exams. But you want to find the domain of the function, find the asymptotes, vertical and horizontal, find the intercepts, x and y, and then get into the calculus, right? First derivative test, all the stuff that goes along with that. Second derivative, right, and the concavity. Then, using all that information, sketch the curve. So let's begin. F has domain. Now you might notice that we could rewrite this as x over x plus 3 times x minus 3. Right? So there are 2 points where we would be dividing by 0, two values of x. Make sure to get both of them. All right, so all the real numbers except 3 and negative 3. All right. Well, that means that we have 2 vertical asymptotes, right? Now, this is a little bit annoying, right? Because that means we have to take left and right-hand limits of both negative 3 and positive 3. So, a little bit of work, but that's going to be okay, right? We can do this. Limit as x approaches negative 3 from, let's say, the left side. Now, remember, this is a little bit backwards sort of from before, right? Negative 3 from the left means that when you square it, it's actually a little bit bigger than 9. So the bottom is positive, the top is negative, and we have a limit of negative infinity. Now, when x approaches negative 3 from the right, now we're talking about like negative 2.999, that kind of stuff. So x squared minus 9 is actually less than 0. Right? So now we have negative over negative. We actually have positive infinity. Let's just do this again, right? Limit as x approaches positive 3 from the left. Remember, in this case, we have a positive over a negative. So that is also negative, right? And sure enough, we do it this way. We have a positive over a positive, okay? We didn't need to do this limit stuff right here to know where the vertical asymptotes were, what the vertical asymptotes were, but we still need to do it. Okay? Now, as for a horizontal asymptote, I'm hoping you can see that it's going to be y equals 0 because the degree of the top is lower than the degree of the bottom. So I hope that you can see this, but if not, then, just save that statement until the end. But we have the limit as x approaches infinity of x over x squared minus 9, right? Of course, we multiply by 1 over x, and we get that this is the limit as x approaches infinity of 1 over x minus 9 over x. And I think at that point we can see that it's 0. By the way, you can do the exact same thing for the limit as x approaches negative infinity of f of x, right? So we covered both. But do remember, get positive and negative infinity. They both count. X needs to approach both. Okay? Next up, intercepts. So I guess we can say f has y-intercept f of 0. Let's move this down a little bit. I had to cramp that style. F of 0 equals 0 over 0 squared minus 9, which last I checked was 0. Actually, let's just keep it like that. Similarly, f has x-intercept. Hope you can eyeball this one. 0. But if not, then you could say it's where... Give this a little bit more room. f of x, which equals x over x squared minus 9 equals 0, i.e., at x equals 0. Okay? So, them's our two values, right? It's the origin, right? We know our graph goes through the origin. Great. Looks like we can squeeze a little bit of calculus onto this page. Right, now we did all the pre-calc stuff. We know the asymptotes, we know the intercepts, the domain. Let's just go to the calculus. First derivative. Gonna be a little bit involved, right? Chain rule, quotient rule, right? F prime of x equals low d high minus high d low all over low squared. Definitely a good idea to simplify this, right? I think we're going to get negative x squared negative 9 all over x squared minus 9 quantity squared. I know it looks like we should be able to simplify, but we actually cannot. It's annoying. Just to show you why, right, you could do that. Right, you just can't simplify it, right? I also hope we see that this does not equal 0. Right? Make sure I did that correctly, right? ID low, yeah, right? Just one of these weird problems, right? It doesn't equal 0. Now, that said, the derivative could totally change because f prime... Oh, gosh, I gotta keep leaving more space here. Because f prime does not exist at x equals negative 3 or positive 3. Okay? Always keep that in mind. Alright, can we squeeze the second derivative stuff in here? I hope so. Remember, I'm going to do the second derivative stuff now and save the write-up and the chart for later. Alright, let's take the second derivative. Whew. Low d high, not awful yet. Times, I guess that's negative 2x, right? Minus high, so I guess that's going to be that. It's going to be minus, becomes into a plus. D low, ugh, chain rule, right? Yeah, all over low squared. And actually that's getting squared, so it's really that. Alright, before we figure out whether that equals 0, maybe we gotta simplify this. Actually, first what we ought to do, a nice way to simplify, knock it off, knock it off, knock it off. Alright? Very important to do. Makes things a bit easier. Alright, now it looks like at this point we can do... I think we're going to have to multiply this all out. And I don't think there's an easier way to do this. So that's going to be negative 2x cubed plus 18x plus 4x cubed, right? Because this is 2 times 2x times this stuff. Plus 36x all over this stuff. Remember, it's cubed because we canceled out a copy. When we do this all out, let's see, I think we're getting 2x cubed plus 54x over x squared minus 9 cubed. Let's just double check that derivative really quickly. Low d high minus high d low. Yeah, looks good to me. I think it's fine. Alright, so anyway, gonna kind of abuse notation. I'm gonna make things look a little bit worse. Shift this over. Maybe we'll factor something out here. Factor out a 2x. From the top, we get x squared plus 27 right there. And then we have an x squared minus 9 cubed. And I hope we can see that this equals 0 at x equals 0. And also f double prime does not exist at x equals -3 and +3. Put that in parentheses right there. Okay. All right. Whew. Right, just to be clear, this is always positive, right? It's never equal to 0. Okay. All right, so let's draw that chart of ours. So what? It looks like -3 and +3 are values of import, as well as 0 for f double prime. All right, well, f prime looks like the top is always negative and the bottom is always positive. Right? Okay, I guess so. Well, I guess that means that we've got that, right? That's okay. Sure. Yeah, I mean, I don't know what more to say. That's looks like what it is. Yeah, wow, okay. Anyway, right, it's -9. Yeah, okay. Anyway, f double prime, let's see. We've got something a little more interesting here, I think. All right, we plug in, I don't know, -10 or something. 2x is negative. This thing is always positive. So the top is negative. Whoops, sorry, that's a -3. And the bottom is going to be positive. So it's a negative over a positive, so I believe it's negative. Okay, and I think that matches up here. So anyway, let's see what we've got here. -3 to 0. Well, we've still got to plug in like -1, right? Negative, positive, negative. So I think that gives us a positive. Now, from 0 to 3, if we plug in 1, I think we're getting a sort of similar thing. Oh, no, the top is positive, the bottom is negative, so we're negative. And, of course, if we plug in a value bigger than 3, I guess we got that. All right, so what does that mean? Our graph is going something like, that doesn't quite seem right. Doesn't quite seem right. This graph ought to be increasing somewhere, I would think. Oh, no, you know what it is? We've got asymptotes to worry about. So it's probably something like there, there, and then there. Something like that. Yep, that seems about right. Looking forward a little bit, right? All right, anyway, let's write a bunch of stuff down. F is decreasing on its entire domain, right? It doesn't ever seem to be increasing. And never increasing. F has no critical points. But it does have critical numbers. -3 and 3. F has no maxes or min, no local maxes or mins. F is concave up on, let's see, -3 to 0, union 3 to infinity, and concave down on, well, the other stuff, right? -infinity to -3, union 0 to 3. But has no inflection points. Right? Because the only places... Oh, wait, no. Sorry. I lied. It does have one. I was going to say it can't... because the only time it equals... Or it doesn't ever equal 0. It doesn't exist at -3 and 3. But it does equal 0. At 0. And has 1 inflection point. 0, 0, right? The origin, right? Now, how did I get this 0? I plugged it into f of x, right? 0 over 0 squared minus 9. All right, with all of that out of the way now, we can sketch the graph of our function. And I think this the chart is very helpful in this regard. So I like to have it with me when I do some sketching. Now, first, I think it's good to plug in our points, but I think that's the only point that we have. Maybe we should include our asymptotes, vertical, horizontal, right? That's what... Nah. Alright, okay, whatever. Still going like that, okay? Alright, so it looks to me like if we know that 0 is the horizontal asymptote, y equals 0, and we've got a decreasing, sort of decelerating curve, it's going like, right, down like that. Ugh, try and draw it a little bit nicer than that. That's pretty good, okay? Then, decreasing but concave up, right? That's something like this. And then it actually decides, no, I'm going to decrease concave down. And it says, well, actually, I'm going to decrease concave up. So that's what we've got. Okay, that's the sketch of our curve. So a pretty involved problem, a bit tougher than I would give on an exam or a quiz, but definitely a good one to understand. Thanks for watching.